So we've got 3.2 here. I know it doesn't say 3.2, but generating electricity is the second topic for core, year 10. And for a change, I'm going to start kind of in the middle. Name the 10 forms of energy. So you might be familiar with 8, but we'll use 10 in GCSE. So light, sound, chemical, kinetic, thermal, gravitational, elastic, nuclear, magnetic, and electrical. I should have a question in here that says, or alludes to the fact that energy cannot be created or destroyed. It can only be transferred. So energy cannot be made. There's a finite amount of energy that exists, and it just converts from one to the other. We've got a table here to show, or with some examples. So you've got a filament lamp. So that's just a normal light bulb. Energy input, what goes into that? Well, electricity. What comes out that's useful? Light. What it gets? Wasted heat, especially the old light bulbs. The newer light bulbs now are more energy efficient because they lose less heat. So mobile phone, well, it's a battery, so it's a chemical energy that's going in, even though we've got to keep charging it from the electricity. The power source is chemical. Useful, well, we get light from the screen, we get sound from music, and if we need to speak to someone, and also kinetic. If you put your phone on silent, it'll vibrate when someone's ringing you. Wasted energy there, it does get warm, so we don't need that energy, so it's wasted. A slingshot, so elastic potential energy goes in as you pull the elastic back with the object in it, whatever you're going to shoot. The useful energy is kinetic. It makes that object move. Wasted energy, it's going to make a sound, and we've got absolutely no use for that sound. It's just wasted energy back into the environment. I'm trying to think any more on energy. Give the formula triangle down here that links energy, power, and time. So there's the formula triangle. In the front of your books, it's going to be E equals PT. So energy, which is measured in joules, power, which is measured in watts, and time, which is measured in seconds. And I've got a typical question here, a 2 kilowatt. So kilowatt is going to be 1,000 watts, is left running for 2 minutes. So a 1 minute equals 60 seconds. How much energy does it transfer? Well, I've rearranged my equation. I've put my finger over E, which is PT, so P times T. So that's going to be 2,000 because it's 2,000 watts, 2 kilowatts, times 120, which is 2 minutes, 120 seconds. And that gives me 240,000 joules, which is 240 kilojoules. So we can either put the answer like that or just in joules, leave it. I'm trying to look now if there's anything else connected with energy before I push on. And I think that's about it for energy. Let's go down here now to list non-renewable energies. So the 4 non-renewable energies is oil, gas, coal, and nuclear. Now you might be surprised by nuclear because it is a clean energy, but it's not renewable. We can't replace it. Once that fuel, uranium or whatever fuel they're using in the nuclear reactor is gone, it's gone. So it's a non-renewable energy. It means it will run out. Again, I'd like to get on this. What does the term non-renewable mean? I think it might be up in the other corner. List renewable energies. So there's 7 main ones. We got solar, which comes from the sun. Wind, from wind turbines. You see them on top of mountains. Geothermal is the one we get from the ground. So if we dig deep enough, then the temperature is going to remain really constant underground. Especially if we can get an area like where there's a volcano, where the ground is very hot, like hot springs, you get areas like that across the world. If we actually dig down and send water down into the earth, the earth is hot enough to boil that water, so it turns that water into steam, very similar how a power station runs anyway, and that steam will drive a turbine, which is connected to a generator, which generates electricity. So that's geothermal. Biomass is what we get from burning trees and woods and plants, anything that's grown naturally, if we burn it. And there's a term called carbon neutral that comes from biomass, where it will release the same amount of carbon that it's sort of taken from the atmosphere. So we call it carbon. So even though it's polluting the atmosphere, it's only polluting it with what it's taken in from the atmosphere. Hydroelectric is when you've got when you build a dam and you've got potential energy. So you've got all water behind like a big dam, and then we can choose to release that water then through very specific and pinpointed places. And when the water falls, it's going to drive a turbine, and that turbine is going to generate electricity. Wave power, so just like when you go down Barry Island, you see the waves. I know they're small, but in areas where there's big waves, you can use the kinetic energy from the waves, that movement energy, to make turbines move. And then tidal power, again, sort of using the energy of water. As the tide comes in, we can use that kinetic energy to drive turbines. So all these really good ideas. But as you'll see, there's advantages and disadvantages. So advantages, they can be renewed, they're replenished. So basically, they're going to last forever until the generator or the turbine needs to be renewed. But the energy source, it will never run out. It will always be there so long as we have Earth. Does not contribute towards global warming, apart from the the biomass, which does contribute towards global warming, but not in the sense that it's going to remove that carbon dioxide anyway, so it's carbon neutral. So it's clean, most of it, well, all of it's clean energy really. And once it's set up, it's pretty much free, even though they've got high decommissioning costs and commissioning costs. Generally, once it's set up, your energy's for free then. So I've said high commissioning costs, so that's building costs there. So the cost it would take to build a hydroelectric power station is massive, absolutely massive. But once it's set up, it's set up. It also impacts on environment. So things like hydroelectric is going to damage the wildlife that's living in that area. Sometimes it's visual pollution as well. People don't like looking at massive turbines on a countryside hill. Same as solar panels. They can be quite ugly on the top of roofs. So it does impact the environment. And sometimes they're unreliable. So you get things like solar panels and wind turbines. Well, if it's not windy, you don't get power. If it's not sunny, you don't get power. You don't get energy. So that's the disadvantages of renewables. Let's go then. I think there was advantages of non-renewable energy. So the advantages of non-renewable energy, which is coal, gas, oil and nuclear, is easily accessible. We can get, we've been digging it up for years, and not with, we don't, even though it's a massive business now, even back when we had basic tools, we were able to get things like coal, oil, gas, and that's how we started to generate electricity, really. So it's really accessible, it's cheap to mine, and it's really cheap and safe to transport in the right conditions. So transporting coal, not a problem. Transporting oil, okay, gets a little bit dangerous. Gas is probably the most dangerous one to transport, but it's quite safe. And we're already set up for it. If you buy a car today, it's going to be running on petrol, probably, unless you're willing to pay that extra and get a hydroelectric car. A hybrid car, hydroelectric. Yeah, they're cars powered by water. It's not going to happen. And then you've got disadvantages of non-renewable energy sources. Well, it's harmful to the environment because of CO2 and SO2, sulfur dioxide as well, which is going to contribute toward acid rain. Quick crossover link there with chemistry. And it will eventually run out. So our sources are finite. As soon as all the oil is gone, as soon as it's finished, it's done. We're done with it.